Hello and welcome. This is going to be our homework help video for the initial value and rate of change homework. We start with the definition of a linear relationship. I'm going to skip down to here. A linear relation also has a degree of 1. It's the correct answer there. This means the highest exponent on any variable in the relation is 1. I'm not going to test you too much on that. Pretty much everything we see is going to be a linear relationship, but now you know what the definition of it is. Let's go into example 1. Mr. Smith is running 2 meters every second. So I can represent that in a table where I can pair x, which is going to be the number of seconds that he has run, to y, which is the number of meters he has run. So if he runs for 0 seconds, he's gone 0 meters. 1 second, well, 2 meters per second. So per 1 second gives me 2 meters. And I can fill in a whole bunch more of these. I always like to count up by ones in my x column. Makes finding the rate of change much easier. And let's then count by 2's over here, because for each second, he's going 2 meters further. What's this going to look like when graphed? Well, I've got a point there at 0, 0, because this row of the table gives us the ordered pair 0, 0. We've got another ordered pair at 1, 2 from this row. The next one's at 2, 4, and so on. 2, 4, 3, 6, 4, 8. You'll notice these are making a straight line, and we can actually connect those up with a straight line. Just like that, to represent all of the positions of Mr. Smith as he runs forward in time. In the scenario above, the linear relationship between the two variables, we have time, represented by x, and distance, represented by y. As a general rule, measures of time can usually be represented on the x-axis. That's a good thing to remember. We almost never put it on the y-axis. In the above scenario, the initial value was 0. He started at 0, so we know the initial value is 0 from the setup. Rate of change is also called the slope. It can be calculated by finding the change in y over the change in x, is how we've been saying it. So now we're going to actually go backwards from table and graph back to just rate of change. We could also find starting value, but we're just going to focus on rate of change, which means I need to copy down those tables, that table again. And now I need to go backwards, or to 9 for some reason. So what I do when I'm trying to find the rate of change from a table is I look at what we're incrementing by in the x column and in the y column. Over here, we're bumping up by +1s. +1, +1, +1. That means delta x equals 1. We're increasing, we're changing x by 1 each time. Let's see what's happening to y. It's going up by 2, up by 2, up by 2. That means that delta y is equal to 2. And if we plug that into our formula, delta y over delta x, we'll get 2 over 1, which equals 2. So that's how we find rate of change from a table. And we had our graph here. Let me recreate it really quick. Looks kind of like that. What we need to do is create a right angle triangle that touches 2 points of the line. The bottom piece is going to be our delta x. In this case, I've drawn it as a 3 units over. And this side over here is going to be our delta y. It's going up 1, 2, 3, 4, 5, 6. Let's use our formula again. Delta y over delta x equals, in this one over here, it's 6 over 3. But you'll notice that still simplifies to 2. So that's how we can go from graph back to rate of change and table back to rate of change. So we should be able to go between situations, tables, graphs seamlessly at this point. Let's take a look at the back side. A CD rental agency charges a $100 flat rate and $50 for every hour rented. complete a table of values for the scenario. So again, we normally put time as our x variable. So I'm going to say x, which is going to be hours. And our y value is what changes because of the time. And here it's the cost in dollars. If we rent for 0 hours, it's going to cost us $100. That's what is meant by a flat rate. You pay it no matter what. You rent it for 0 hours, you still have to pay that $100. We rent for 1 hour. Well, we got to pay the flat rate plus the $50 for the hour, so that takes us up to $150. 2 would cost us $200. 3, $250. 4, $300. 5, $350. What's the initial value of the linear relation? Well, we can go back up to the scenario and see that it's 100, or just look at our graph that the number across from 0 is a 100. So we know our initial value is 100. Put that on my graph right now if I want. What's the change in this relation? Well, we can go back up to the situation and see that it's 50. Or we could calculate it from our table now and see that we go up by 1 on this side, up by 50 on this side, and delta y over delta x equals 50 over 1, which equals 50. All right, let's plot these like ordered pairs, just like we did on the front side. I've got 0, 100, 1, 150, 2, 200, 3, 250, and so on, going up like this. Here we actually probably wouldn't want to connect these with a straight line. We're not sure how they're going to charge us for fractional amounts of hours, but my guess is they're probably going to round up, meaning this would be a stepped graph. But I'll connect it with a dotted line because we just don't know what we would have to pay if we brought it back after half an hour. All right. Example 3, Mr. Shaw's bank account. What's the initial value of this one? Well, now we got to find initial value from a graph. To do that, we got to look where are we crossing our y-axis. It looks like we're crossing 1, 2, 3, 4, 5 units up. But notice these are counted by 50s, so it's actually $50. This is initial amount. Rate of change, let's add in a slope triangle. We can add it wherever we want. I could add it right here, for example. And see that when I go 1 over, I go 5 units up. But again, that's counting by 10. So this is actually a 50. As our rate of change is also 50. 50 over 1 is 50. Let's look at this one over here. Initial value of 350. You can see it right there. That's where it crosses my y-axis at 350. And when I can make a slope triangle like that. Let's look back at the scale. That was only 1 unit across the bottom, 10 units on the side, but I'm going downhill, so this is going to be a -10 for my rate of change. -10. All right, last thing, positive rate of change is increase from left to right, negative decrease from left to right. And ignore this. This was the homework. All right, have a good rest of your day.